Welcome to GCSE Maths Foundation Unit 2, and this is all going to be algebra today. So we're going to be collecting like terms, simplifying expressions, expanding, factorising and substituting as well. So everything that you see in Unit 2 of the algebra course. So let's get started. Hopefully you have got yourself the worksheet. It is down below in the description, but also hosted on my website as well. Download this worksheet. The idea would be that you complete the first side along with me. Then you would pause the video, do the exam questions that are on the back or on the second sheet, and then play the video again to go through those with me. So let's do it. There are X pens in each box and there are Y pencils in each jar. Write an expression for the total number of pens and pencils in 3 boxes and 2 jars. So if there are X pens in a box, let's draw a box like this. If I've got X pens in there, and I've got X pens in there, and I've got X pens in there, well, it says I've got 3 boxes. So that means I've got 3 lots of X, whatever it is. We don't know what it is, but I've got 3 lots of X. If there were 5 pens in each box, you would do 3 times 5. If there were 7 pens in each box, you would do 3 times 7. So we're just going to multiply the number of boxes by how many pens are in each box. So that is 3x there. And also we have Y pencils in each jar. So if we have a jar and we have another jar with Y pencils in each, that is 2 lots of Y. So altogether for the pencils, 2 lots of Y. Now it says write an expression for the total number of pens and pencils. So we want to add these 2 things together to get the total in 3 boxes and 2 jars. There we go. 3x add 2y. Now you can't make that 5xy because these are not like terms. So when we are adding and subtracting, we need to think about, are they like terms? Have they got the same variable, the same letter? And if you can add x's with x's, or you can have y's with y's, but we can't add x's to y's other than just writing it like this. So following on from that, nicely, to simplify t, add t, add t. And these are like terms. I've got a t, I'm adding another t, I'm adding another t, so that would be 3t. Now, just a side note, if it had been t times t times t, that would have been t cubed. But that's because they're multiplying together. So when we multiply something by itself and by itself again, we are cubing it, and that would be a power of 3. So if you put that, you were close, but it needed to be 3t for this one just because you are collecting them up, adding them. So hopefully then this should make sense. A multiplied by A multiplied by A multiplied by A is going to be a to the power of 4. When we are multiplying them together, that power is going to increase. And then below I have 3m squared, add 3m squared, add 3m squared. Now here we are adding. So it's a little bit more like this, and also I guess like this, in that we can only add them if they are like terms. If I've got an m squared and another m squared, another m, they are all like terms, so I can collect them up if I'm adding them. And I've got 3 lots of m squared, another 3 lots of m squared, and another 3 lots of m squared. So altogether, that is going to be 9m squared. And I think there would be a temptation to put m to the power of 6, but that would only happen if we were multiplying. So again, m squared multiplied by m squared multiplied by m squared, that would give me m to the power of 6, because when I multiply, I can add the powers up. But that's only because we're multiplying that happens. Here, we were just adding them up, collecting them up to say I've got 9 lots of m squared. Great, so moving down, I have got some indices here, the powers. H to the power of 3, and then that is being raised to the power of 5. Now a power of a power, when that happens, we multiply those powers together. So 3 times 5 is 15. This is h to the power of 15. For the second one, b cubed multiplied by b to the power of 5. When we multiply, we add the powers. This is saying b times b times b, that's b cubed, and I'm multiplying it by b times b times b times b times b. That's b to the power of 5 there. And if I multiply all of that together, in total, we are doing b to the power of 8. So when we multiply that like that, we can add the powers. Last one down here then, I can do 2 multiplied by 3, which is 6. And then g squared multiplied by g to the power of 4 is a little bit like we had here. If we are multiplying them together, g squared means g times g, and then g to the power of 4 is g times g times g times g. So altogether, I've got g to the power of 6, and that is going to be your answer there. Next section, and I have 7 multiplied by e multiplied by 6 multiplied by f. And because this is multiplying, we can do 7 times 6, which is 42. And then I'm multiplying that by e. And when we multiply with algebra, we just write it next to it. And then we're multiplying by f. So 42ef there. We can put them together because we're multiplying. If we were adding, we could only add e's with e's, and we could only add f's with f's. Here, this is very similar to the one we did up here. I've got m cubed and I'm adding another m cubed. Now we're adding. Are they like terms? Yes, they are. So I've got 2 lots of m cubed all together. That power isn't changing because we're not multiplying. And then at the bottom, simplify a to the power of 4, m to the power of 3, all divided by am squared. Now that's quite tricky, but what we can do to make it a little bit easier is firstly just look at the a's. If I have a to the power of 4 and I'm dividing that by a, that's the same as a to the power of 1, when we divide, we take away the powers. So a to the power of 4 divided by a to the power of 1 is just a to the power of 3. And then I've got m cubed and I'm dividing by m squared. So again there, when we divide, we take away the powers. And that would be m to the power of 1, but we don't need to put that 1. M to the power of 1 is just m. So your answer there is a cubed m. When we divide, we take away the powers. Okay, back up to the top then. Arthur is p years old. Mary is 3 years older. Write an expression for Mary's age in terms of p. So let's say Arthur was 10. Then we know Mary is 13. Let's say Arthur is 15. Then we know that Mary is 18. We're just going to add 3 to whatever it is. So I know that if I was going to write that in terms of p, I need to start with p, which is Arthur's age. And we know to get to Mary's age, we need to add 3. And that is it. They are not like terms. 3 is a constant term. It doesn't have a variable. It doesn't have a letter. And p is a variable. It's a letter. So we can't put them together. If you wrote 3p, that would mean 3 multiplied by p. So that's no good here because that's not what's happening. We're just adding 3 on. So p add 3 would be your answer there. Next, we need to think about like terms again. So we're adding. So I can put the c's with the c's. And remember that the symbol, so if it's an add or a take away, belongs to the term that comes after it. So if you've got minus 5c, then we need to take away 5c. So let's look at the c's first. I've got 3c, take away 5c. Think about your number line. If you are at 3 on the number line and you take away, you're going to go this way. You're going to go down past 0, 1, 2, 3 to get there, 2 more to go, so minus 2. So minus 2c is me collecting the c's together. And then I'm going to have to do 8b, add on 1 more b, and that brings me up to 9b. And then often students will say to me, but what symbol goes here in the middle? And because that 9b was a positive 9b, if I put a plus here, that plus belongs to the 9b. So it tells us it's positive 9b. There we go. And you could also have written that as 9b take away 2c. That's exactly the same. As long as the 9b is positive and the 2c was a takeaway because it was negative, then that is a correct answer there. For the next one, we're going to simplify 10y squared, take away 12y squared, add 3y squared. Now we are adding and subtracting again, so we need to think about our like terms, except these are all y squared. They are all like terms. They've got the same variables. Y squared, and y squared. If I have 10 lots of something, I take away 12 lots, I'm going to go down to minus 2. 10 take away 12 is minus 2, and then I want you to add 3 to that. Now, if you're already at minus 2 and you add 3, you're coming up past 0 to 1. So our final answer is 1y squared, and you would be okay to write it like that, but we're mathematicians, we like being efficient, and we don't have to write that 1 because y squared also means 1 lot of y squared. So this would be my preferred answer here, but if you put 1y squared, that would be fine. You would get full marks as well. Next, we are asked to factorise, and you need to see that word factorise and just think brackets. Factorise means putting into brackets. When we expand, we come out of brackets, and when we factorise, we put back in. And factorise has a clue in it, in that it starts with the word factor. So I'm going to look at 8t and 12, and I'm thinking to myself, what is the highest common factor? What is the biggest number that fits into both an exact number of times? And that's going to be 4. 8 is in the 4 times table and 12 is in the 4 times table. So let's put 4 outside our bracket. Always bring the biggest thing you can outside the front of the bracket. And then I'm asking myself, 4 multiplied by what would give me 8t? And I need a 2 and I need a t for that to happen. And then 4 multiplied by what would give me 12, positive 12, and I need that to be 3. 4 times 3 is 12. For the second bit, factorise fully. 10a squared minus 15ab. Now here, what do they have in common? Let's look at the numbers first. I've got 10 and I've got 15. They are both in the 5 times table. So let's pop a 5 outside like that. I also, however, have an a. This is a squared, which means a times a. And this is ab, that means a times b. So in terms of what is in common, it's going to be an A, so we can pop that outside the bracket as well. Now, the fully was a clue. If it says factorise fully, the fully is a clue that more than one thing can come outside the bracket, and we always want to take as much outside the bracket as we can. So I've got 5a on the outside, and I'm going to need 2 here, so that the 5 times 2 makes 10, and I also need an A. So 5a times 2a is 10a squared, and then 5a times what to make 15ab? Well, we need that to be a 3, and we also would need b, and that's going to be a takeaway there in the middle because we have a takeaway up there. So 5a times 2a is 10a squared, and 5a times 3b is 15ab, and we have that being taken away there. Okay, last but not least on this middle section, 8x to the power of 5 divided by 2x cubed. Now, 8 divided by 2 is 4. They are normal numbers. When we divide them, we know what's going to happen there. 8 divided by 2 is 4. Now with the powers, you've got x to the power of 5, and you're dividing it by x cubed. And when we divide, we take away the powers. So that is going to be x squared. Your answer there, 4x squared. Moving over to the third section over here, I've got to expand the brackets. So this is the opposite of what we just did by factorising. We're now going to bring these things outside the brackets. So 5 lots of 2t and 5 lots of 5. When I write a bracket like this, it means 5 lots of everything that is in that bracket. Take that bracket and multiply it by 5. So 5 lots of 2t is going to give us our first term. That is 10t. And 5 lots of 5, we're multiplying that together, and that is going to be 25. So 10t add 25. I can't make that 35t or bring them together in any way because they're not like terms. I've got 10 lots of t, so that has the variable t, and then I've got 25, which is just a constant term there. So we can't bring them together. For the next bit, I've got 3 lots of this bracket, and then I'm taking away 2 lots of this bracket. Okay, so let's do that in turn. 3 lots of f and 3 lots of 8 is 3f add 24, because that's 3 times f and 3 times 8. And then I'm taking away 2 lots of 5f, which is 10f. But here is where students often get stuck. We've done that bit, but now I'm doing minus 2 lots of minus 3. I'm taking away 2 lots of negative 3, and it's a negative times a negative, which means that fourth term is going to be add 6, because minus 2 times minus 3 is positive 6. Now we've expanded, we've done that bit, and now it's our job to simplify. So that means we're going to collect any like terms. I have 3f, and I'm taking away 10f. So if I start at 3 on the number line, and I take away 10, I'm going down past 0, I'm going to keep going, and that is minus 7f. And then I've got positive 24, and I'm adding on 6. And that brings me up to 30. So my final answer there, minus 7f add 30, and again, absolutely fine to write it as 30 take away 7f, as long as it's the 7f that's negative and the 30 that's positive. Okay, last but not least on this section, I have 3h squared multiplied by 5h minus 7k. And again, we're going to do what's on the outside multiplied by the first thing, what's on the outside multiplied by the second thing. So 3h squared multiplied by 5h. 3 times 5 gives me 15. And then I have h squared, and I'm multiplying that by another h, and that is going to be h cubed. Then let's use our takeaway here. 3h squared multiplied by 7k. 3 times 7 gives me 21. And then I've got h squared multiplied by k. They're different letters. We'll just write them next to each other. H squared k there for your final answer. They're not like terms. I can't bring them together. So that is it, our final answer there. Last section on this page, and we are substituting. It says m is equal to 9t minus 3v. And that means 9 lots of t, they're multiplying together. And then we're going to do 3 lots of v and take it away. So to get m, we need to use these values. Now they're telling us that t is worth 3 and v is worth minus 2. So let's do 9 lots of 3. That t is now becoming 3. We're popping that there. And the v is becoming minus 2. So take away 3 lots of minus 2. And you might find it helpful to put them in brackets. So you're going to do the multiplication parts first. So 27, take away, and 3 lots of minus 2 is minus 6. Now, if you take away negative 6, it's the same as adding it on. So that is going to be 27, add 6, which is 33 as your answer there. And at the bottom, I've got h equals 5b squared. So 5 lots of minus 4 squared, because they've told us that b is minus 4. And then we're going to take away 4. Now, which bit of that sum are you going to do first? So we need to think about bib maths and the order of our operations. We want to square the minus 4 before we multiply it by 5. So minus 4 squared, when we square a number, we're multiplying it by itself. So minus 4 times minus 4 is a negative times a negative, which is 16. That's the first bit I'm doing. Minus 4 squared is 16. This bit here has a value of 16. Now I'm going to multiply it by 5. So 5 lots of that is 80. And then take away 4 is 76. So 5 lots of 16 is 80. That was how we got that bit there. Take away 4 is 76. And that is that page done. So hopefully you've got lots of lovely notes to help you. You're now going to pause the video, turn your paper over or go on to the second page, have a go at all of the exam questions that I've put on the back. So all of these are taken from actual exams. And you can have a go at those, see if you can build on what we've just seen, and then watch the video again and we'll go through the answers to these as well. Okay, let's go through the second side. There are Y boats on a lake and there are 7 people in each boat. Write an expression in terms of Y for the total number of people in the boats. So an expression should never have an equal sign. That's going to be an equation if it's got the equal sign, or maybe a formula. An expression shouldn't have an equal sign. Here we're just trying to say how many people are in all of the boats. So if there were 2 boats on a lake, we would do 7 times 2. If there were 10 boats on the lake, we would do 7 times 10. But here there are Y boats on the lake. So we need to do 7 times Y, except we wouldn't write it like that. When we multiply together in algebra, we just put 7Y. So 7Y was your answer there for 1 mark. Then we need to simplify 5p, take away 3p, add p. Now people always say with bib maths that you should add before you subtract, but actually we should write bib maths like this. And if you've done my Unit 1 video, we did discuss this in the Unit 1 video. So division and multiplication are on a level, and so are addition and subtraction. So if you have 5p, take away 3p, and then you add p, don't do this bit first. We're just going to work from left to right because addition and subtraction are on the same level. So 5p take away 3p is 2p. That's that bit. And then we're adding on 1 more p, and you can put a 1 in front if you find it helpful. 2p add 1p is 3p for that one there. For the next one, m cubed add m cubed is 2m cubed. And y times y times y is y cubed. Notice the power didn't change here because they were the same. I was just collecting them up and saying I've got 2 of them. Down at the bottom, I've got m squared to the power of 3, and we know that a power of a power, we multiply them together. X to the power of 5 times x to the power of 8, when we multiply like that, we are adding them together, so that's x to the 13. 3 times a times 4, well, 3 times 4 is 12, and if we multiply that by a, we get 12a. And down at the bottom, m, add m, add m, add m, is 4m. If you wrote m to the power of 4, remember that would be m times m times m times m. When we multiply, it increases the power, but adding, we're just collecting them up and saying, I've got 4 lots of m. In the middle at the top, let's have a look at our like terms. I've got 4 lots of x, take away an x, and I've got 3, and I'm adding on 5. So altogether, I've got 3x, because that's 4x, take away 1x, and then I'm adding on 8 from the 3, add the 5. They are not like terms, the x's and the constant term here, the 8, so that has to stay like that. Then for the next bit, we have 10. Now that is the only constant term, so that guy is staying on his own. Then I've got 3c, take away 7c, and then I've got 5d, add 1 more d. So altogether, the 10 is just staying on its own. If I have 3c and I take away 7, imagine you're at 3 on the number line, you take away 7, you're going down to -4. So that's -4 lots of c from the 2 yellow ones. And then 5d, add on 1 more d, is 6d altogether. Now you didn't have to write them in that order, as long as the negative is with the 4c. So let's say you wrote 6d, take away 4c, add 10. That would be absolutely fine as well, as long as it's the 4c that's negative. I mean, you could even put it in the front, -4c, add 10, add 6d. Those two terms are positive and the 4c is negative, so any of those would be fine in any order you like. And then we've got 8h cubed, add 14h cubed, minus 2h cubed. And they are all h cubed. We're adding them up, we're collecting them up, and they are all like terms, so that's fine, we can do that. 8 add 14 is 22, take away 2 leaves me with 20, and it's just going to be h cubed. They were like terms, so we could collect them up, so the power is not going to change. Factorize means brackets. When you see that word factorize, you should be thinking, okay, that's my brackets, I need to put them in. I'm looking for a highest common factor, and that's going to be 5. So that goes on the outside of my bracket. 5 lots of, and then it's going to be 3y minus 2 inside the bracket, because we would need it to be 3y to make 15y there, and 5 times 2 is how we're getting the 10 or the minus 10 there. Okay, factorise fully, there's a clue. It's going to be more than one thing on the outside of the bracket, and we want to bring as much outside as we can, always. So 9 and 6 are both in the 3 times table, and x squared is x times x, and we have an x here as well, so x can come outside the bracket. Now, 3x multiplied by what would give me 9x squared? I'm going to need 3. But I'm also going to need another x, because the x times the x is how it's going to become x squared. And then an add goes here, and we've got 3x multiplied by 2. That's how we're going to get 6x. Well done if you got that. Down at the bottom, c cubed divided by c squared. We are dividing, so we're taking away the powers, and that leaves me with just c to the power of 1. But you can put the 1 or not. I wouldn't, because you don't need to. And then we've got d to the power of 4 divided by d. And again, that d on its own is d to the power of 1. D to the 4 divided by d to the 1 is just d cubed. So cd cubed is your answer there. And to expand brackets, we're going to do what's on the outside multiplied by the first thing and what's on the outside multiplied by the second thing. X times x is going to give you x squared. You are multiplying it by itself, so you are squaring it. And then x times 4 is 4x. That is minus 4x going there. Here we've got 2 brackets. 5 lots of p and 5 lots of 3 is 5p add 15. And then minus 2 times 1 and minus 2 times minus 2p. We've got the negative times the negative happening there again. So minus 2 there, and then add 4p. Because negative 2 times negative 2p is add as positive 4p there. Okay, let's collect our like terms. I've got 5p add 4p, which is going to be 9p altogether. And then I've got 15 take away 2, which is positive 13. Great, last but not least, 4p times p squared is 4p cubed, and then 4p times 3p is 12p squared. There we go. Not like terms, can't put them together because p cubed is different to p squared. So there we go, that's that one. And then we have our substitution. So to get t, it's 3 lots of x, add 4 lots of y. So t equals 3 lots of 5, because they've told us that's what x is, add 4 lots of minus 7, because they've told us that's what y is, 15, add negative 28. 4 times minus 7 is minus 28. If I'm adding a negative number, it is the same as taking away. So this question is asking me 15 take away 28. It would take me 15 to get there, and I would have 13 more to go. So minus 13 would be your answer there. And then we've got p equals 4m squared take away 11, but we're told that m is negative 3. So let's do 4 lots of negative 3 squared take away 11. And we know that we do the squaring first. Minus 3 squared is 9. It is minus 3 times minus 3. You're timesing it by itself, so that's 9. 4 lots of 9 is 36, and then we're going to take away 11, so you have a final answer of 25. There we go. That is all of that done. That is all the algebra that comes up in Foundation Unit 2. Hopefully you found that helpful, and I look forward to seeing you guys next for Unit 3. Keep an eye out for that. Let me know in the comments down below if you've got any questions.